Hey everyone, Nick Russo here. Today I'm going to do something a little bit different, where I'm not going to have a perfectly produced technical deep dive or training series, but instead I want to have a casual conversation about a very important topic. There's this belief among CCIE candidates that you have to get all the core routing technologies correct on your exam before you can even consider doing things like IP services or QoS or security topics. That's just not true. Sometimes you're going to get core routing questions in the exam that are extremely important to the functionality of the lab that you just don't know how to solve. And I want to teach you 2 ways to work around those problems, and these might help you pass the lab. I promise this isn't clickbait, so just bear with me as I explain these methods. The first is doing the wrong thing on purpose, and the second is not doing the right thing. And I know this sounds counterintuitive, but I want to walk through 2 examples. Suppose we get a question like this on the lab exam. It says, ensure host 1 can ping host 2. And you can see from this network, we've got 4 routers. They're running OSPF. We've got 3 different areas. It's a pretty basic design. We have a limitation that we cannot create any tunnel interfaces. So we need to solve this using some kind of intrinsic OSPF feature. There might be an obvious solution to this problem. And maybe you tried that solution and you can't get it working, or maybe you just don't know what that solution is and you're stuck early in the exam and you're starting to panic because you don't know how to get past this problem. If you've been studying for the CCIE for any period of time, you probably know that the desired answer is probably an OSPF virtual link from R2 to R3. This would connect R3 back to the backbone, it would make R3 an ABR, and it would allow Area 2 and Area 0 to communicate across Area 1. However, like I said before, if you try to configure a virtual link and it doesn't come up, and there could be many reasons for that. For example, there could be an OSPF path cost that's greater than 65535 across Area 1. There could be some ACL that's blocking the unicast OSPF messages between R2 and R3. There could be some phantom authentication enabled for Area 0 that you didn't know about. There's a million things that could go wrong. If you can't get it working and you want to move on to other tasks, just do the thing that they told you not to do. Create a GRE tunnel from R2 to R3 and enable OSPF Area 0 on it. Yes, this is not the same thing as a virtual link, and it has different forwarding characteristics and has a different impact on the OSPF database. I am not saying that they are exactly the same. I'm saying that they are similar enough to where you would be able to ping from host 1 to host 2, and you would be able to continue with the lab. You are going to forfeit the points for this question, but it will allow you to move on because there are a lot of points later in the test with the security, the IP services, the QoS, etc. If you don't even get to that point in the test, which happened to me in my first attempt, you have no chance of passing. This approach allows you to trade off 2 or 3 points to potentially gain 20 in the future, so it's absolutely worth doing if you don't know how to continue. The second example is don't do the right thing. It's basically the opposite of what we just discussed. Rather than a task restricting what you can do, it might tell you specifically what you must do. So for example, in this topology, it says configure PPPoE from R1 to R2. That's pretty simple, tells you exactly what to do. It then tells you to make some modifications like enable OSPF on it with some specific cost. Now you need to read between the lines here a little bit. You don't have a lot of flexibility here. It's telling you to do a very specific thing, but the relevance of the OSPF cost might be important later. For example, maybe all those other links in the topology have various costs, and the lab designer is trying to make it so that your routing is asymmetric across R1 to R2 for whatever reason. This means that the OSPF cost is really important, but if you can't even get PPPoE working, how is OSPF routing going to work? Well, just don't do it. Skip PPPoE if you don't know how to configure it or if it doesn't work. Don't waste any time trying to make this happen. Just work around it. The trick is to try to make the interface look as much like a PPPoE connection as you can. That means using an OSPF point-to-point network type, configuring the manual cost of 30 that they wanted, and adjusting the MTU. Some of you may know that PPPoE comes with an 8-byte overhead encapsulation, so you want to be sure to include that. By making that link look like a PPPoE connection to the maximum extent possible, the other routers in the topology will be able to function the way they should. This will provide the correct routing thanks to the cost, and if there's any data flowing across it, maybe later in the lab they want you to deal with some TCP MSS adjustment so the MTU becomes relevant. I think you get the idea. Just make the link look like it's supposed to, even if you don't understand the core technology. Again, you're going to forfeit the points for this question, so you'll lose your 2 or 3 points or whatever, but it opens up another 20 points later in the test that you can at least attempt. I don't want to drone on about this. If you're studying for the CCIE, you're already busy, you're already studying all the time, and I don't want to make that worse by talking needlessly. So I'm going to end it here. When you're performing your studies and attempting a full-scale practice lab, try to incorporate these techniques into your studies and see if it gives you a better score or allows you to finish the test with some more time left over. If you can finish most of the exam with time left over, you can always come back to these tasks later and try to fix them and make them work, and then redo your verification. The thing you absolutely must avoid is don't let these stop you dead in your tracks, because then you'll have no chance of passing. Okay, I think that's enough. If you've enjoyed this and you want to see more like it, leave a comment below and tell me what you think, and if you have any other questions, I'm happy to answer. I've also linked some training resources in the video description if you'd like to learn more about how you can improve your skills to attempt the CCIE lab. So until next time, everyone, take care.